Okay, welcome back. It has been like forever since you have done geometry. So I'm going to tell you this now. Number one, this video is the only video that there is for 8.1. In fact, I'm going to try to do all of chapter 8 with just one video for each little day. But that requires you to do some work ahead of time because you still need to make sure you write down all those postulates, theorems, etc. on that sheet. You need definitions that I go over that are new to you. You need to make sure you write down. Now, here's the really hard part. You've been away from this for a while. You know when you take a break from math for a while that you come back and it's hard for you to remember everything that we've gone over. So, before you even dive in any more to this video, go back and reread all of those postulates, theorems, and definitions. Go back. I know you don't want to. I know it's a lot of work, but I'm telling you, go back and reread them, not just once, because I need to make sure that you remember all that stuff so that you can do your stuff faster. If you get confused or frustrated because it's taking you too long, it's probably because you're not remembering something that we expected you to remember. Because I expect you to remember everything I've gone over, and I know that's not always easy to do. So please make sure you go back and look at that stuff. Before you try to go through this video, go back and reread it all at least twice. Okay, moving on. Section 8.1 had very little information in it that is really important to you, but lots of problems that you can work with. The reason why is there's one really important theorem and another offshoot of that really important theorem. So the really important theorem is this one. The altitude to a hypotenuse of a right triangle forms two triangles that are similar to the original triangle and to each other. Okay, so I have my little right triangle here. I'm going to draw an altitude to the hypotenuse. That means it's going to have to be perpendicular to the hypotenuse and go from the opposite angle down to my hypotenuse. So that would be my altitude. I'm going to call this D so I can talk about some sides here. But basically what it means is that this big triangle has to be similar to this little teeny tiny one and to the middle one. I know that's a lot to do. You're going to have to make sure all your angles are correct. So when you're going through and you're stating things, remember that similar angles have to be corresponding to similar angles. So I would say that triangle ABC, because B is my right angle, is similar to triangle, going with a really small one. I went from my small angle out of my big triangle. So I need to talk about my small angle out of my little triangle, and they happen to be the same. So it's going to be similar to triangle ADB. And that's going to be similar, because they're all similar, to triangle. And then out of this one, my small angle is B. I say it's a small angle. It's really not the smallest angle, but it's the one that has the shortest side to it. So triangle BDC. So all three of those are similar triangles. Once again, you're going to have to make sure that your angles are lining up. So I did the short side first. And then over here, I did my short side first. And then here, I did my short side first, always ending at my right angle. So I could make sure I had it all lined up good. That's important, because if it's not lined up good, it's going to mess you up when we get to the hard problems. Now, since BD, that's this one, is the altitude to the hypotenuse, so we know that because it forms a right angle with the hypotenuse. It is also the geometric mean to AD and DC. So before you left, we had talked about, well, before Christmas break, we had talked about geometric means. And since this is the geometric mean of these two, That means I can take AD, put it over BD, and that has to equal BD over BC. So in other words, this length right here and that length right there have a geometric mean of whatever this length turns out to be. That's excruciatingly helpful for what we're getting ready to do. So since we have this little bit of information, then we can use this little bit of information to start solving our sides. Over here, they only gave me 2 sides. They gave me 6 and they gave me 12. 6 and 12, that's it, no more. They want me to find every other side that there is. So I'm going to start with the information that I know. I know that this has to be the geometric mean of these two. So I'm going to go ahead and write that down. X over h has to equal h over y. Because h is the geometric mean. Of x and y. I'm not trying to prove anything, I'm just writing down my reasoning. You don't have to write down your reasoning, but you do have to know this fact because it's going to help you later. So I'm writing down how I know these facts. The other fact that I know is that they're going to have to be similar triangles. So when I go to write my similar triangles, I'm going to say that this triangle happens to be similar to this triangle, which means they're going to have corresponding sides. So that means that the shortest side here over the shortest side here, or we could say that the shortest side here over the shortest side there, either way, it doesn't matter. X over 6 has to equal, and then I need to go over to some more corresponding sides. So I did my shortest side out of this triangle and the great big triangle. So my medium side out of this triangle and the great big triangle, well, my medium one in the little triangle is H. So I'm going to put my H. That's the longest leg. The longest leg out of the big triangle is B. And then the hypotenuse of the little triangle is 6. And the hypotenuse of the big triangle is 12. So that's the similarity that we are told from having the little triangle being similar to the great big one. This I can do something with, because since I know this, I can get some information out of it. So I don't have to have the HB in there. I can just say this one has to be equal to that one. So I'm going to come over here and I'm going to say, because we know that, because they're similar triangles, so I know that x over 6 has to equal 6 over 12. And in order to figure out what x is, I just do my little cross multiplying. So I get 12x is equal to 36. Divide both sides by 12. X must be 3. Well, that's some information right there. If I know x is 3, what does that mean y is? This is when you're supposed to say what that means y is. Did you say what it means that y is? I didn't hear it, I'm sorry. You're going to have to talk louder. Did you say what y was? If this is 3, then we know that 12 minus 3 is, that's right, it is 9. See, I heard you that time. You've got to speak up. I'm sorry. It's a long distance here we're dealing with. I can't help that part. Okay. So, since we know that y is 9, I don't have to worry about trying to find y. We just found y. But I do need to find h and b. Well, we know that 6 over 12 has to equal h over b, but that doesn't really help me right now. So I suppose I could go, I did the little triangle and the big triangle. How about we go and we do the middle triangle over the big triangle? So looking at my middle triangle, my smallest side is 8. Smallest side of the big triangle is still 6. Middle side of the middle triangle is going to be 9 because it's its other leg. And the middle side of the big one is B. And then the hypotenuse of the middle one is B. And the hypotenuse of the big one is 12. Well, since we need H and B, HB, health and beauty. Since we need them both, I can set them up separately, but I'm going to start with just these two because they both have B's in them, and that might be a little bit helpful. So I'm going to say 9 over B is equal to B over 12. When I do my cross multiplying, I get 9 times 12, that's what, 108? B times B is B squared. Now I can take the square root of both sides. I don't know what the square root of 108 is. I mean, I really don't know what the square root of 108 is. But I know some things that go into 108 because we just got it from 9 times 12. So that's got to be a 3 times 3 times 3 times 2 times 2. So that's 9, that's 12. And I know 2 on the inside make 1 on the outside still. 2 on the inside make 1 on the outside. That gives me a 3 and a 2 on the outside. So that's 6 square roots of 3 is equal to B. Okay. So now all I have to do is find H. That means that H over 6 is equal to 6 square roots of 3 over 12. Instead of putting it here, I put it with the other one. I was hoping it would help. We'll see. So I have 12 times H is 12H is equal to 6 times 6 square roots of 3. 6 times 6 is 36 square roots of 3. Divide both sides by 12. And you get that H is equal to 12 goes into 36. 3 times 3 square roots of 3. Remember, when you're multiplying and dividing square roots, insides times insides and outsides times outsides. Insides divided by insides and outsides divided by outsides. So I found my X. I found my B, that's 6 square roots of 3. And then H turned out to be 3 square roots of 3. Now I did all that with similar triangles. But if I had gone a different direction and I had found B a different way, or I had found H or X or Y a different way, I would have been able to use this. So I'm going to use this one to check my work. I mean, it has to be true because they said it was going to be true. So I'm going to come over here and check my work. We said that X was 3. H we just said was 3 square roots of 3. And then y we said was 9. 3 times 9 is 27. 3 times 3 is 9. And then the square root of 3 times the square root of 3 is equal to the square root of 9, which is really 3. So that gives you 9 times 3, and 27 does equal 27. We must have been right. I'm just saying. We're doing good. Okay, now, I feel certain that you feel like you understood that, but you could never do it. That's okay. You don't have to do it right away. You have to do it right-ish away. So there is some classwork. There is some homework. It's all located on page 308. Classwork is numbers 1, 3, 9, 13, 17, and 21. And then the homework is numbers 5, 7, 11, 15, 19, and 23. For these problems, most of them are going to end up being kind of straightforward. The stuff like this that we did is the last few set of problems. Before that, it's just saying this side's going to be equal to that side, this side's going to be equal to that side, this side is the geometric mean of those two kind of things, which I think you'll be fine at. No proofs. That's nice. You know, you can't just jump back into proofs. It takes a little bit of working up to it, and it's okay because I don't really need you to do proofs for this anyway. I just need you to know why we're doing what it is we're doing, and those two are why. If you have problems remembering about similar triangles, you can go back and look at that section. If you have problems remembering about geometric mean, you can go back and look at that section. I'm just saying, it could be an issue. Either way, let me know if you have questions. You know where I'm at. New rule for 2019 spring, make sure you don't call me before noon your time. That does not mean wait until noon to watch the video. That means don't call me before noon. If you want to watch the video earlier, then you might not have any problems with it, and so you can go ahead and do all your work and everything, be fine, good, and wonderful. So that's okay. Okay, bye!